Hello and welcome class. So in last class we have studied what is weight of an object and what is mass of an object, and we try to figure out the difference between mass and weight. In today's class we are going to calculate the weight of an object on the moon. Till now we have calculated the weight of any object on the moon, on the earth, and its formula was mass into gravitational acceleration. W is equal to mg, where g is the gravitational acceleration of the earth. Okay, what will be the mass of that object if we place that object on the moon? We are going to learn about it. Okay, so weight of an object on the moon. We have learned that the weight of an object on the earth is the force with which earth attract the object. Okay, and that force is equals to weight, which is equals to mass into gravitational acceleration due to earth, small g, where small g depends on the value of gravitational constant, mass of that planet, in this case earth, and radius of that planet square. This is the formula for g, and this is the formula for weight. Clear class? So in the way we calculated the weight on the earth, in that same way we can calculate the weight of an object on the moon. What will be the weight of an object on the moon? It will be the weight or that force with which moon attracts the object. Okay, it will be that force with which moon attracts the object. Clear class? We know that the mass of moon is less than the mass of earth, and we know that g is directly proportional to mass, and mass of moon is less than mass of earth. It means the gravitational acceleration value of the moon will be less than the gravitational acceleration due to earth, and that's why any object which is placed on moon will be less weighted, because the gravitational acceleration is less on the surface of the moon. Due to this, uh, due to the mass which is lesser than that of the earth, the moon exert less force of attraction on the object. Moon will attract that object with less force in comparison to earth, and we are trying to calculate that force. Okay, let the mass of an object on the moon is small m, and the weight of this object on the moon is wm. Let mm, capital M suffix small m, is the mass of the moon, and rm is the radius of the moon. We know that weight on the moon will be mass into gravitational acceleration of the moon, and the gravitational acceleration of the moon will be capital G, mass of moon divided by radius of moon square. Okay, we will put the value of gm on this equation. Wm will be equal to gmm divided by rm square into small mass m, which is the mass of the object. Okay, and what will be the weight on the earth? Weight on the earth will be G capital M small m divided by Rm square, where capital M is the mass of the earth and R, this is R, is the radius of the earth. Clear class? This is weight on the earth, this is weight on the moon. Now we have drawn a table which contain object name, their mass and their radius. Earth has mass of approximately 6 into 10 raised to the power 24 kgs and radius of approximately 6,400 kilometers, so 6.4 into 10 raised to the power 6 meters. The mass of the moon is approximately 7.4 into 10 raised to the power 22 kgs, and the radius in meter is approximately 1.7 into 10 raised to the power 6 meter. Now what we are going to do, we are going to put this value in the formula of Wm and We, and we will try to find out the force exerted by any object due to moon and due to earth. So W earth is Gmm divided by r square, and Wm is Gmm into small m divided by rm square. Is 7.36 into 10 raised to the power 22 kg. Small m is the mass of the object, and Rm is 1.74 into 10 raised to the power 6 square. And when you will complete this calculation, leaving the value of G and M, Wm is approximately equal to 2.4 into 10 raised to the power 10 Gm. This is the weight on the moon. Okay, weight on the moon. And weight on the earth is 1.47 into 10 raised to the power 11 into Gm. This is weight on the moon. When we will calculate the ratio of weight on the moon divided by weight on the earth, we get 1/6. It means the weight on the moon is approximately 1/6 times of the weight on the earth. What does it mean? It means that if your weight is, let's suppose it is 36 kg on earth, then on the moon your weight will become 6 kg only, because weight on the moon is 1/6 time of the weight on the earth, and we know that weight is equals to mass into gravitational constant. Let's suppose gravitational constant of moon is Gm, which will be equal to 1/6. Weight on the earth is m into G. Cancel. So gravitational acceleration of the moon is G/6 times, where G is the gravitational acceleration of the earth. It means the gravitational acceleration of moon is 6 times lesser than the gravitational acceleration on the earth. It means the force applied by moon on an object is 1/6 time that compared to the earth. So moon attract with lesser force on comparison to earth. That's why when you see the images or videos of astronauts moving on moon, you will mostly see that the astronauts are jumping. Why they are mostly jumping? To go from one place to another, because moon attract with less force, so you feel weightless. Okay, you feel light, and you mostly jump to go one place to go from one place to another. Okay, so it is clear to us that weight of the object on the moon is 1/6 time the weight of the object on the earth. Is it clear, class? Okay, let's solve some questions related to it. If mass of an object is 10 kg, what will be its weight on the earth? Mass of an object is 10 kg. Let's suppose your book has mass of 10 kg. What will be its weight? On the earth, how are you going to calculate it? What is the formula used? So weight is equals to mass into gravitational acceleration due to earth. Mass is 10 kg and the value of gravitational acceleration is 9.8 meter per second, and weight is in Newton. So final answer will be 98 Newton. Okay. So if an object which has mass of 10 kg, then earth is attracting that object with a force of 98 Newton. So that object's weight is 98 Newton. Is it clear, class? Let's see its detailed answer. Mass is 10 kg. Acceleration due to gravity is 9.8 meter per second square. So weight will be mass into gravitational acceleration, which is 98 Newton. It means that the weight of the object is 98 Newton. This question was very easy, directly formula based question. I hope everyone understand this one problem. Next question is, when an object is weighted 10 Newton when measured on the surface of the earth. An object weighted 10 Newton when it is measured on the surface of the earth. What would be its weight when it measured on the surface of the moon? Okay, we have to calculate that object weight on moon. How we are going to calculate it? So we know that weight on the moon is 1/6 times the weight on the earth. We just have to put the value of weight on the earth and divide it by 6. We will get the weight of that object on the surface of the moon. Is it clear, class? So let's see its detailed solution. We know that weight of the object on the surface of the moon is equals to 1/6 times the weight of the object on the surface of the earth. The given weight of object on the surface of the earth is 10 Newton. So its weight on the moon is around 1.67 Newton on the moon. Weight of the object on the surface of the moon would be 1.67 Newtons. Okay. This is very, very, very important question. You have to write the differences between mass of an object and its weight. Okay. This is a very important question. And the answer is, mass is the quantity of a matter contained in the body. Number of matter inside a body is known as mass, where weight is the force exerted by any object because of earth. Is it clear, class? Mass is measure of inertia of the body, whereas weight is the measure of gravitational force or gravity. Inertia and weight is measure of gravity. Mass is always constant. It does not depends on place, okay, planet. It is always a constant quantity, whereas weight changes from place to place, from planet to planet. Mass only contains magnitude, only has the magnitude, and those objects which only has the magnitude are known as scalar quantity, and weight, because weight consists of product between mass and gravitational constant, and gravitational acceleration, and gravitational acceleration has magnitude as well as direction. So weight also has both magnitude as well as direction, and those quantities which has magnitude as well as direction are known as vector quantity. The SI unit of mass is kg, whereas the SI unit of weight is Newton. Okay, because weight is a force. Is it clear, class? So you have to remember these 5 differences between mass and weight. Clear, class? Mass is how much matter is inside a body, whereas weight is the force exerted by a body due to gravitational force. Mass is the measure of inertia, where weight is the measure of gravity. Mass is constant, whereas weight varies from place to place. Mass only contains magnitude, whereas weight contains both magnitude as well as direction. The SI unit of mass is kg, whereas the SI unit of mass is Newton. These are the 5 differences between mass and weight, and this is a commonly asked question in ninth class, that write the 5 differences between mass and weight. So this is a very important question. I hope this question is clear to all of you. Next question is, why is the weight of an object on the moon is 1/6 time that of the earth? They are asking why Wm divided by We is 1/6. And the reason is because the mass of the moon is very less in compared to mass of the earth. Okay. Because gravity is directly related to mass. Okay. And moon is a smaller planet, a smaller celestial object. So its mass is very much less than the mass of the earth, and gravitational acceleration is directly depends on mass. That's why the weight on the moon divided by weight on the surface of the earth is equals to 1/6. So gravity is directly related to mass. The more mass of an object has, the more gravitational pull it has. Now the moon is significantly smaller than the earth. Okay. There is a small fact that the size of the moon is equals to size of earth core. It is that small. Okay. And gravitational force depends on the size of the object. That's why the weight on the moon divided by weight on the earth is 1/6 times. Clear? So from that topic, weight on the surface of the moon, we have completed the first part of the gravitational topic, which is gravity. In the second half of the gravitational chapter, we are going to learn about liquids. Okay, pressure exerted by a liquid, what is the force inside a liquid, why uh, some object sink in the liquid, where some object float on the liquid, what is Archimedes principle. Okay, these questions we are going to answer in the second part of this chapter. Okay, and the first topic of the second part of this chapter is thrust and pressure. So have you wondered why camel can easily run on in a desert but you cannot? Why the army tank weighted more than thousands of tons uh, are rest upon a continuous chain? Whenever you will see a army tank, its wheels are different. Okay, a chain is going around the wheel, and that's how army tank move, and the weight of any army tank is more than 1,000 tons. So why we use that chain system instead of tires? Okay, why truck or motor bus has much wider tire in comparison to your cycle tire? Cycle tires are very, thin, whereas the tires of a bus or a truck is very wide. Okay, why when you want to cut any fruit or vegetable, the knife has a very sharp edge? Why we need sharp edge to cut anything? Why not a blunt edge? We are going to answer all this topic. In order to address these questions, I have capitalized the word question, because we are going to answer all these all these questions now. Okay, to address all these questions, we have to first understand what is pressure and what is thrust. So let's understand what is pressure by some situation. Situation number 1 is, you wish to fix a poster on a bulletin board. As shown in this figure, a boy is trying to fix the newspaper on a bulletin board, and he is pressing the pins from his thumb. Okay. To do this task, you will have to press drawing pins with your thumb. Okay, as shown in that figure, the boy is trying to press the pins with his thumb. Okay, so what he is trying to do, this is the surface of the pin and this is the rest of the pin. That boy is trying to push the pin with his thumb. So what he is doing, he is applying force. He is applying force and this is the surface. So the force is perpendicular to the surface. Okay, surface. So he is applying force perpendicular to the surface area and he is applying the force on the head of the pin, which is much more wider in comparison to tip of the pin. So that boy is applying force from his thumb, okay, perpendicular to the surface area, and he is applying the force on the head of the pin, and the head of the pin is very much wider as compared to the tip of the pin. So that force is actually going to the tip of the pin, which has very small surface area, and much smaller the surface area, higher will be the value of the force. Okay, that is situation number 1. Situation number 2 is you are standing on a loose stand. Okay, whenever you stand on a loose sand, your feet will go deeper into the sand. Okay, and if you try to lie down on the sand, your body will not sink. Okay, when you are standing on a loose sand, your feet will go deep, but when you lie down on the sand, okay, you will find out that your body is not going deep in the sand. Why it is happening? So we have learned that weight of an object always act in downward direction. This is an object of mass m. Then gravity always act downward. So weight always act downward. Okay. And this is the surface. So force is always perpendicular to the surface. Okay. And when you are standing on a loose sand, okay, these are your feet. When you are standing on a loose surface, your weight is going down in downward direction. So your feet also sinking in downward direction on the loose sand. So the force acting on an object perpendicular to the surface is called thrust. Whenever any force which act perpendicular to the surface is known as thrust. When you stand on the loose sand, the force, that is your weight of your body, is acting on an area equal to the area of your feet. The contact area between sand and your body is your feet. So you are applying force perpendicular to the surface, and your surface area is equal to area of your feet. When you lie down, okay, same force is acting, but area is getting increased because whole sand is in contact of your whole body when you lie down on the surface of the sand. So the force spreaded in a larger area. Magnitude of force is same, but the force has spreaded on the larger area. That's why you don't sink when you lie down on the sand, and you start sinking on the loose sand when you are standing on the feet, because area has changed. Your surface area when you were standing on the surface of the sand is the surface of your feet. But when you lie down on the sand, then the surface area is your whole body, which is very large in compared to the surface area of your feet. That's why the magnitude of force haven't changed. The magnitude of force is still mg, but surface area changes. Okay? And because surface area changes, you stop sinking in the loose stand when you lie down. So in both the cases, when you were standing, the magnitude of the force, which is weight or your thrust, was mg, and when you were lying down on the sand, the force was still the same, but surface area changes. So important thing is surface area changes. The effect of thrust sand is larger while standing than compared to while lying. And thrust per unit area is called as pressure. We have defined a new term named as pressure, which is the perpendicular force, which we called as thrust, okay, or perpendicular force divided by area. Perpendicular force divided by area. Okay. In other words, the force was same, but when you were standing, the surface area was small. And because surface area was small, pressure was high, and pressure was high, so you start sinking. But when you lie down, your thrust was the same, but your area increases. Okay, your surface area increases, so your pressure decreases, and because pressure decreases, you stop sinking in the sand, on the loose sand. Is it clear, class? So in today's class, we have completed the first part of the chapter, which was gravitational force, and now we have started the new part of this second part of this chapter, which is thrust and pressure, and we learned about what is the definition of thrust. Thrust is the perpendicular force from to the surface, and what is pressure? Pressure is thrust upon area, and we learned about pressure from the example of loose sand. Is it clear, class? In next class, we are going to continue this topic, thrust and pressure, and we will try to finish it in the next class. So I hope this class is clear to you. Now we will meet in next class. Thank you.